Hi everyone, my name is John Chun. Today I'm going to present about our research topic which is on the training and testing data preparation for end-to-end text-to-speech application. This work is in collaboration between our university which is FPD University and UCSI University and Tiaga Raja College of Engineering. So here's our presentation agenda. First, we will go through the introduction, followed by methodology, research results and analysis, and conclusion. And finally, there are some references in the work. So let's go through the introduction. As you may see, in recent years, there are significant development in text-to-speech engines, such as WaveNet, WaveGlow, Tacotron, Tacotron 2, ES Tacotron 2, Transformer. And these engines are being used in developing applications such as chatbots, voice bots, automatic call centers, etc. Typically, the TTS applications are machine learning based, and they need large data sets. Usually for TTS topic, it requires over 10,000 of text lines and audio files correspondingly. And it is very time consuming for data preparation in case someone starts entering this TTS area. So in recent works, they do not discuss how to prepare the dataset yet. Therefore, this work addresses these issues. And you can find the open source code in the reference 17. Here it comes to research methodology. And as you can see from the figure here, we have the software architecture. Usually for running this algorithm, you will need a transcript file in form of the TXT format. And for us, we develop a junk.txt file which is used to store all the files that you do not need from the dataset. So sometimes when you work with the dataset, there will be certain files or certain lines of text that you do not want to include into the training and testing of the model. So simply you can put all these file names into the junk.txt file. And you can have a file name which is metadata.csv, which is used to store the data file that will be used for the training and testing of the TTS engine. So all this information will be fed into the data preparation algorithm that is developed by us, and then we will prepare the metadata.csv file which can be used to train and test the TTS engine. So here it comes to our presented algorithm in forms of the source code, pseudocode. At first, you have to import the important libraries such as OS, sys, and datetime. The language we use here is the Python. And in order to measure the running time, you can set the T1 is equal to current time. And then in the third step, you set the essential parameters such as dataset. This one is the dataset name, txt source file, txt prefix in case you want to include into the transcript that is created later on. And you have the f method to store the metadata file. And next is the fjunks to store, which is storing the file name of the junks.txt. This one actually you can change as long as what you want. So in step 4, you will check if the path txt underscore source exists. So this is the path to the source transcript file. In case the file exists, you open the file And if when you open the file, you set the ICSGRC equal to 0, then you start to read each line in the file and assign it to a variable data. In case the data reaches end of file, you break the loop, else you open the fjunks file. So when you open fjunks file, you will check whether um, the file listed in the tst underscore source exists in fjunks. This means that you do not want to include this file into the final transcript that you will use for training and testing of the TTS engine. So when you are reading the fjunk files, you read each line in it, and you assign it to data junk. In case data junk reaches EOF, you will break the loop. Else, if the data junk is found in the data, and you set is junk is equal to 1. In this case, the line of text in the source file is found in the junk files. This means you do not want to include this line into the training and testing data set. And finally, you close the fjunks. So if the isjunk is equal to 0, then you split. This means that the file is not excluded by purpose. So it means you have to include this file into the transcript that will be used for TTS engine. So in case you found this line of text which is needed, then you split the data into strings using the vertical separator as the delimiter, and you assign the results to a variable x. Next, you set the x2 is equal to the results when you split the x0, the first element of x, by the keywords delimiter .mp3, and then you find the data to write, which is the tst prefix plus x2, the first element of x2 plus vertical separator plus the second element of x and the new line character. After that, you open the metadata file and append it to n, and finally you close the file. So this is run through all the text lines inside the source text. Finally, you close the txt source file, and then you set the t2 is equal to current time. After that, you calculate the processing time, which is equal to t2 minus t1, and you can analyze the processing time based on the different data set. So here it comes to the FPT open speech data overview. So actually we are using the FPT open speech dataset, which is released available and freely available for everyone. And it consists of roughly around 30 hours of data of speech, which is significant for use in TTS engine. So as you can see that the speech will have the MP3 format, and it has the name here, FPT open speech data underscore, the set number and version number. You can have version 1, version 2. Here's the first time they released it, so the version is 0.1. And there's few other parameters which is indicating the file name or the file order in the dataset. And then you have also the TTS input, which is the file name here, .mp3, and the text, which is the transcript that you will use for TTS engine. It is end-to-end text-to-speech application. They also indicate the starting time and ending time of the file. And here's the results that we have so far. So whenever you have the input text like this, you have the output text which can be used for TTS engine. This is data to write. As you can see there's a file name here. Then there's a text line. This is the transcript that you input to the TTS engine. So by processing like this, you will be able to produce a transcript file which can be used directly for Mozilla TTS engine. And as you can see here, it's average processing time. We have tested the work for different datasets provided by FPT Open Speech Data. As you can see from the table here, almost the mean processing time per line is roughly 40 to 70 microseconds per line. And the data set for the set 1 is roughly 14,000 files. Set 2 is roughly 12,000 files. So as you can see that even though the part 2, set 2, part 1, it has only 525 files. The mean processing time per line is the longest one. So this actually depends on the platform and also the hardware architecture that you use for running the algorithm. And here it comes to the CPU and RAM information that we have used using the Google Collaboratory, which is totally free. Everyone can use this one. As you can see, we have two processor core inside the engine, which is Xeon 2.3 gigahertz, and the total memory free, which is roughly 12 gigabytes. Roughly 12 gigabytes. So this is totally free, and not everyone can have access to this information um, individually if they want to buy the hardware themselves. So Google Collaboratory is one of the good platform for starting the machine learning and artificial intelligence application. And here's our source code, which is freely available and everyone can use. We put it on GitHub here. And in conclusion, we have presented an open approach for generating and training and testing data for end-to-end Mozilla TTS application. And we released the software publicly and everyone can use it. And we have used Vietnamese open source voices from FPT operation, which is FPT Open Speech Data for training and testing of the TTS engine. And in the future, we will introduce an approach to perform text cleaning for Vietnamese, which is very and critically important because it will affect the performance of the TTS engine later on. So here are some of our references that probably you want to have a look at it. At them. So with that, we would like to thank you for your attention and listening to this presentation. In case you have any questions, please feel free to drop us an email or comments on our video. So thank you very much.